Good morning, good afternoon, or good evening, depending on where you are in the world. And welcome to this learning experience brought to you by Fairwinds. My name is Cody, and welcome back to Techstrong Learning. We've got an exciting presentation ahead, but before we dive into things, I have just a couple of notes I'd like to review with everyone. First of all, we are recording today's session. So if you happen to miss any of our discussion, if you'd like to rewatch, or if you'd like to share with your team, you will be receiving an email with a link to access our recording on demand, and you'll be receiving that email shortly after we conclude today's live session. Now, if you'd like to get involved with us in this presentation, there are a couple of ways to do so. The first way is to use that chat tab on the right side of your screen. So when you find that chat tab, let us know from where in the world you're joining us from. Now, if you have any specific questions, we do want you to send those into the Q&A tab on the right side of that chat section. We've got plenty of time set aside to address your questions today, so feel free to send them in, and we're going to do our best to answer as many as we can. Additionally, we will be selecting 2 of our most engaged attendees to receive a $50 Amazon gift card. So ways you can engage with us is, like I said, you can chat with us, you can submit questions, or of course, you can fill out our post-webinar survey, which will be posted in the handouts as well as at the bottom of the chat here toward the end of our program. So our topic is building a better Kubernetes platform, the art of Kubernetes RightSizing. And joining me today is Joe Pelletier, Vice President of Product Strategy at Fairwinds, and John Slivka, Senior Kubernetes Engineer at Fairwinds. So Joe and John, thank you both so much for joining us today. Joe, do you want to dive us right into things?
Yeah, absolutely. So excited today to talk about the art of RightSizing. This is kind of an area that Fairwinds has a lot of kind of experience in, especially with our open source project Goldilocks. But if this is your first time kind of learning about Fairwinds, I'll just give you a quick overview of who we are. We're really a company that provides software for platform engineers to help them run Kubernetes and standardize and enable great best practices for their Kubernetes environments. And best practices can range from security, enforcing good reliability and efficiency standards, as well as making sure you can automate and help ship applications faster. And so that's sort of the core of what Fairwinds does as a business. I think we do have a quick polling question, though, Cody, to kind of kick things off. And I'll turn that back over to you to maybe kick off that polling question. But it's really asking, how over-provisioned do you think your Kubernetes environment is today? And I think this is kind of an interesting question because a lot of times, we work with customers who are, either trying to explicitly tackle over-provisioning or are also, not sure how to measure that today. And so I think it will be interesting to see kind of where the audience is on this question. Looks like we've got some results coming in. And, interestingly enough, so far, it looks like not sure, don't know is about half the responses. As well, and in second place, it looks like over-provisioning a lot of over-provisioning is sort of the other kind of response category that's coming in right now. So not surprising. I think this is becoming more and more of a challenge for organizations. And we're hoping today to give you a little bit more kind of context around what is it, why is it hard, and some ways you could potentially tackle that. Awesome. So we'll move ahead just kind of with the presentation here. And really the first kind of discussion question that John and I will, open up here is really kind of what is RightSizing and why is it hard, right? And so, John, do you want to kind of help us understand a little bit more around like kind of what is the concept of RightSizing as it relates to Kubernetes and containers?
Sure. So RightSizing is tough for a lot of reasons, but one is kind of based around the topic of quality service, which I think we'll touch on a little bit later, but the risks are pretty bad in both directions, right? So the consequence of over-provisioning is a little bit more clear. Your organization's spending way more money than they need to, sometimes a lot of money in some cases. And then the consequences of under-provisioning are a little more nuanced, right? There's different things that can happen with the scheduler and C groups. So we'll get into that a little bit more, but The consequences of under provisioning are poor reliability or poor availability, right? So you can have both happen. The scheduler might kill one of your pods if you have not requested enough memory. You might start getting throttled when you're not expecting it. So these are kind of things that you need to balance and trade off, and you really need to have a solid understanding of, what's peak load look like, what's typical load look like, how, bursty is your workload, for lack of a better term, and then how much do you prioritize things like reliability and availability.
Yeah, makes sense. And I think that's also, to your point, why it makes it hard, right? There's a lot of things that you have to balance here. And, one of the things that we've observed when we're talking with different customers in this space is some of the challenges are around who actually is responsible for right sizing and what tooling is out there to kind of give great recommendations that is, informed by data. And I think a lot of challenges that we've seen with organizations is there's a guessing process today around guessing what resources a Kubernetes application might need, and that's hard to guess correctly. And so I think one of the implications of that is a lot of times applications might be over provisioned, and we'll share some data that we recently published as part of our benchmarking report around that problem. So this is actually, I think, a good segue into talking a little bit about this concept of resource requests and limits. Resource requests and limits, I think, are sort of the core aspect of being able to kind of right size correctly. And so, John, do you want to kind of explain a little bit more around what these concepts mean in Kubernetes and sort of help us understand sort of the how they're used by Kubernetes today?
Sure. So, request is conceptually just that, right? I am asking the scheduler for a slice of our cluster. And a limit is an upper bound on how much of that I can use. So that becomes really important when you start to have resource contention. Now, the difference between CPU limits and memory limits and CPU requests and memory requests are quite consequential. So I think it's important to just touch on how they're different and how it will impact the things I talked about, like reliability and availability. So the CPU limit is a kind of a hard ceiling on how much of the host processor you can use, how much clock time you can use. So once you hit that limit, it's going to start throttling your workloads so that other workloads coming in have that clock time available. A memory limit is a little bit more of a hard thing, right? If I hit memory limit, the kernel is going to say, okay, I'm going to send a signal to kill this process because it's using too much memory. So that's where you're going to have availability issues. It's a little more nuanced with CPU because you're just going to start getting throttled and you're going to see the performance of your application start to degrade. So that's limits at a high level. The requests is also a bit nuanced. So with memory requests, it's kind of a hint to the scheduler to say, okay, I want to use this much memory. That's somewhat straightforward. CPU requests are more like a wait. So if you don't have a lot of workloads running, you might actually have 100% of that available compute on that node. But when you start to get contention, that CPU request is actually used as kind of a waiting to prioritize certain workloads. So if you have all your workloads in, say, a node pool or a single node, they're all weighted equally, and that might not actually represent what you're trying to do in terms of this workload should have precedence over this one. So that's a really important thing to understand.
Yeah, that's super interesting, and I think one of the kind of going back to sort of the challenge here is getting those values or setting the correct values around whether it's memory or CPU requests and limits often becomes sort of this guess by engineering organizations. And so in this kind of example here, you might have a Kubernetes pod that has requests and limits set, but after running that pod in a cluster for a period of time, you might realize that the actual usage, whether it's from a memory perspective or a CPU perspective, could either be much less than what is minimally reserved by Kubernetes, even after long periods of time, or it could be much more than what's requested and bumping up against limits. I mean, there's a variety of scenarios there. And so this concept of right sizing is really trying to make sure over time that the pod specification is balancing the right amount of requests and limits, so that you're not over spending or over committing resources that you don't need. But to your point, conversely, you're not also running into these reliability scenarios where you're running out of memory or not meeting your availability SLOs. And so this is just an illustration, I think, on this page that shows an over-provisioned pod and the desire to right size it to the correct resource requests that it's needed. So we've one of the things that Fairwinds has done is we've actually published a benchmark report earlier this year around analyzing a lot of the different types of metrics that our customers and various different kind of organizations have around resource requests and limits today. And what we've noticed is about almost a quarter of organizations today have about 30% or more of their Kubernetes workloads running without memory requests. And so this notion of over provisioning and setting too much memory or CPU is a problem, but a more basic problem is not even setting these values to begin with and kind of letting Kubernetes guess. And that can also open up kind of other types of challenges. So John, maybe you could help us understand, like, when Kubernetes is running a workload and you haven't set sort of the requests or limits, what does Kubernetes do? Does it guess itself, or like what's some of the implications of that?
So essentially, it does not have a lot of information to use at that point, because there's not really historical data with the scheduler itself. The C groups that you have there don't have any historical information about what your load has been like in the past. It only knows what's going on right now. So it's really important, especially for things like setting memory requests, that you have the amount that you think you'll need, and you don't get killed, right? Because that's really going to kill your availability. And especially for web applications, that's going to turn into a 500 for your user. And if you're running maybe processing a data set or something, maybe you have like a batch workload that's doing some ML stuff. So given a certain data set, that's probably never going to complete, right? If you don't have enough memory. And that's a pain.
Yeah, very good point. And I think what we've noticed is the trend line is actually that this concept of workloads being deployed without memory requests and limits, it actually seems like it's a growing problem. Looking back last year, about 40% of workloads, for example, 46% of workloads were running, 46% of organizations only had about 10% of their workloads impacted with this problem. But looking forward in this year into 2023, you can see that that percentage has actually increased. And so I think that this is a sign of, as organizations adopt more and more Kubernetes and containers, they're realizing that they need to put processes and tooling in place to properly set these values. And that's some of the ways that Fairwinds helps, both from an open source perspective and from our commercial product. So once you set the resource requests and limits, the problem of over provisioning is actually the biggest of the problem space I think that we're seeing. So 82% of organizations are setting their memory request too high, which is really, when they have to set those values, I think what we find is lots of DevOps teams or developers, they kind of guess at how much memory and CPU they need. And so they tend to put values that are very high or very, heavy amounts of putting very large values in their memory requests or CPU requests. And that's causing Kubernetes to, reserve a lot of extra compute, more than it may actually need. And so ultimately, the implications of that is really kind of inefficiency, right? If you, for example, set memory requests or CPU requests too high, it causes those workloads to use more resources than they need. And that can affect your ability, that can add to your compute costs, which ultimately means you have to buy more nodes or instances from the cloud provider. Or if you're running in an on-premise data center, it might mean that you're over consuming the fixed amount of compute available in that data center, and fewer applications could be deployed, or fewer applications can run because you're overcommitted there. So again, it really can affect the bottom line from a finance perspective. This ultimately, this kind of guess that developers and engineering teams make early in their Kubernetes journey. You mentioned earlier, John, about quality of service. Can you kind of share a little bit more around that concept? And we're talking about having to set memory and CPU, and setting the right values is important, but what values you actually set really comes down to this concept of quality of service. So can you share a little bit more about this concept as it relates to Kubernetes?
Yeah, so I think without even getting into the SRE topics of how do we measure things like reliability and availability, you can start with what's kind of production customer facing workloads versus what's not, right? So that could just be a pre-production environment you're staging, or development environments. Maybe you just don't have that level of, you don't have those high availability or reliability requirements in a lot of cases. So that's just a great place to start there. But also just back of house things. Maybe you're processing reports, or you're doing, like I said, ML pipelines, data processing. That maybe needs to complete overnight, but it doesn't necessarily need to be done, right away. So that's a really good place to start. And beyond that, you start getting into availability and reliability. So I think it's helpful to take a look at those things, look at your historical trends, see what percentage of your requests are currently failing. If you're trying to make your application more reliable, and start looking at maybe setting your requests and limits closer to each other. So at Fairwinds, one of the rules of thumbs we talk about is burstable versus reliable workloads. So in a burstable scenario where, maybe most of the time your application's not doing much, but maybe you get a spike in traffic for a certain service around noon for about an hour, right? That's a burstable workload. Most of the time we're not using those resources, nothing's going on, and then all of a sudden we got to scale up. So in those situations, you can have your requests set lower than your limits. And if reliability, kind of at the other end of the spectrum, if you need reliability above everything else, you should probably have your requests and limits equal to each other. So you have that guarantee, there's not going to be any fluctuation. When a pod gets scheduled to a node, you're guaranteed that you're not going to get throttled. You're not going to have eviction. The scheduler is going to respect the resources you've set aside.
Excellent. Yeah. And one of the other things that we've heard from customers is there's certain workloads that might be very mission critical, right? They need to have, in all cases, kind of more than enough resources available so that you don't run into any of those unforeseen issues of kills or throttling. And we've introduced this concept of a critical quality of service that really adds additional kind of headroom and above and beyond kind of the historical usage that we've seen in our product. So that's another quality of service that some organizations may choose if they're really concerned about availability. So that's a great overview, John, of quality of service. So far at this point, we've been talking a lot about, really kind of the concept of vertical scaling of pods, right? Making sure that you're setting sort of the memory and CPU, but there's also this concept of horizontal scaling. So help us understand that concept, right? I mean, it sounds like it's another way, another kind of factor in terms of being able to, properly size and scale your workloads.
Sure. Yeah. So the huge advantage of using containers over just bare metal instances or virtual machines is that startup time, right? You don't have these long, protracted cold start times. So assuming you have, a good sized pool of compute, if traffic comes in, we can start to scale based on things like CPU and memory utilization, and that is much more responsive. So the trade-off we're getting there is, when we're in kind of cold times, maybe there's low load, and then we all of a sudden spike, like that, 12 p.m. lunchtime spike, we can scale up quick without sacrificing availability. And that's where tools like the horizontal pod autoscaler are very, very useful and a good cost-saving tool.
Yeah, and it's really kind of making those different replicas of that pod, to your point, so that you can, again, serve more users and have more kind of resilience in terms of the operation. There is another concept around right sizing that we hear from organizations, and it's really kind of like node right sizing. So far we've been talking a lot about right sizing at the container level, which we see as sort of this emerging problem as organizations adopt a lot of Kubernetes. I think a problem that is being tackled today and has there's a lot of different kind of options out there is really node right sizing. But help us understand, what is node right sizing, John, and like how does that how does that differ from, I guess, the container right sizing we've been talking about?
Sure. So unfortunately, I don't have any diagrams, but there's a fantastic presentation that's a little bit old by Kelsey Hightower, and it's called Kubernetes for Sysadmins. But essentially what he does is he pulls up a game of Tetris and starts to move blocks down and try to match those blocks. Basically makes an analogy to the Kubernetes scheduler, right? But I think on the topic of node right sizing, you want to make sure that your workloads are homogeneous enough that they can all fit efficiently in that node, right? So that might mean having workloads with similar compute to memory ratio and using that to choose a certain type of instance. That's really important. Especially with early adoption, you'll see folks just kind of pick like the default node type and then not put a limit on their node pool size. If you're in Google, for example. I think that's kind of a big faux pas in early adoption, is not setting limits on how big your node pool should be. And that's where costs can really run away, is especially if you don't have your request set properly, that's where you're going to be spending a lot of money really quick. So that's an important thing to keep in mind. And then going back to the topic of production versus non-production workloads, making decisions about, could I use cheaper commodity hardware here? Do I need, high performance compute? Mm-hmm. And putting your mission critical stuff in a separate area from, maybe your back of house pre-production environment. That's really important.
And is the concept of kind of choosing between spot instances and sort of dedicated instances, is that another kind of dimension of node right sizing here?
Yeah, for sure. So that's another huge cost saving opportunity, and looking at, can this workload be preempted? Maybe it's, it goes back to that idea of quality of service, right? If you can kind of isolate all of those types of workloads to a specific node pool, that's a much better way to save money. So I don't know if did I touch on what you're looking for there, Joe?
Yeah. No, I think that's helpful. Because I think right sizing it's multidimensional, right? It's not just fixing your containers; it's also adjusting sort of the nodes in your cluster as well. And I think increasingly we're seeing the cloud providers, for example, offer different types of managed options where you don't have to necessarily worry about node right sizing. They kind of manage that for you. And so I think that's another trend in this space where when you do move to the cloud, there are these options where you don't have to focus on selecting the right nodes. You can choose services that manage that for you, which really means that at that point you're really focused on sort of container right sizing and making sure your containers are properly sized so that you're not overspending there. So I think just to kind of take a step back around ways that Fairwinds can actually help with right sizing is we have open source in this space called Goldilocks. That's actually our popular open source tool for generating recommendations at the workload level around different resources to right size. And we also offer kind of a more robust commercial offering called Fairwinds Insights that provides this right sizing advice. And really it's meant for enterprises that have to scale this out beyond just kind of one team or one app, and bring this advice and bring these recommendations into multiple different teams. So Fairwinds Insights has been designed for sort of that platform engineering user who is trying to enable different development teams to be successful with deploying to Kubernetes. we can also provide those same users with right-sizing advice for their services. So, not only will the product help you identify where there's areas of wasteful CPU and memory spend, but we can also help you take action. So you can get resource recommendations that are easy to implement, as well as apply policies so that you can enforce best practices like labeling and prevent workloads that might be over-provisioned or have missing requests and limits. So what I'll do now is just kind of give a quick demo of how Fairwinds helps here, and give you a better understanding of sort of, where not only in the Fairwinds Insights product these features live, but also, the business value around this as well. So let me go ahead and share kind of our demo environment here at Fairwinds. So the first thing that you'll see is Fairwinds Insights is our enterprise product. It's available as software as a service, but you can also run it as a self-hosted instance. And it's multi-cluster from the start. So you can add as many clusters as you'd like to Fairwinds to get a sense, to be able to kind of look at and provide right-sizing recommendations across the enterprise. We specialize really in two different areas. One is on cost allocation, so helping you understand the costs of those different workloads, as well as container level right-sizing. So those are the two use cases that we really focus on today. And what I'll show right now is a little bit around our cost allocation and right-sizing capabilities. So we can make this concept of setting resource requests and limits a little bit more real. So the first thing that you'll see is, again, Fairwinds kind of provides a historical view into your Kubernetes costs. And so you can go back as far as 13 months to look at that. And you can also, look at costs across multiple clusters as well. So I'll go ahead and I will kind of select all the clusters in my environment. And the first thing that you'll see is that there's a number of different ways you can aggregate and roll up the data. So for example, you could look at information, on a namespace level. And, here you can see that the kube system namespace, which exists in every one of my clusters, is actually costing my organization about $400 over the last 30 days. As a result of understanding the build cost, we can generate kind of recommended cost, which sometimes is a little bit more, or a lot of times much less than what the build cost is. And the recommended cost is really the impact, the financial impact of applying the recommendations that Fairwinds is generating. And so on average, we do see about 30% kind of cost savings across our customer base when it comes to applying right-sizing recommendations. Another really cool thing is you can kind of sort by label. I think a lot of organizations are also rolling up or using labels increasingly to help, do finer grain organization of their apps. And you can see right here, I've got a namespace here called, or a label here called Polaris. It's costing me about $21, but if I were to apply the recommendations from Fairwinds, it would only cost me $4. So I've got some savings opportunities. So let's actually kind of dig into that as an example. I'm going to go and start digging into some of my workloads here. And the first thing I'm going to do is actually kind of sort by the cost savings opportunities. This is actually going to give us a better way to kind of understand where do I have the biggest, where do I have most of my over provisioning, and what can I do to actually save money. And so the first thing you'll see is when I click onto this workload, I've actually got 30 days of historical usage here. And I can see that, the actual requests, CPU requests right now that are set are 100 millicores. But if I apply the Fairwinds recommendation, I actually can reduce the amount of CPU that I'm requiring by lowering that to 25. Now, from a memory perspective, I've got a similar story here. I can actually reduce my memory requirements as well. And so I can lower the amount of memory I'm asking for this application based on the historical memory usage too. The concept of quality of service is also kind of is built into this product. So if I want to get different recommendations based on different quality of services, I can do that. And this helps the developer kind of just understand, like, if it's a really critical application, maybe I go and take a more conservative recommendation by selecting critical, and I'll get a slightly different recommendation as a result. So that's one of the ways that Insights can provide you with sort of a tool that allows you to find these recommendations and kind of be very direct to the developer around what that resource request and limit should be, so that they don't have to go and guess or make a lot of trial and error to figure that out. Now, one of the other things that's important about beyond just generating these recommendations, the other thing that's important is also being able to help developers take action. And so there's really two ways I want to show you how we can do that. So whenever there is a recommendation for a workload to be right-sized, you can will generate kind of essentially a finding in our product. And there's an opportunity here to kind of create a ticket into a backlog so that a developer can get this information into their backlog so they can prioritize it as part of their kind of development process. And so, whoops, of course, the demo gods didn't work on that one. But, basically being able to create the ticket in the backlog is one of the other core ways that, developers can kind of get this visibility. The other way that you can bring visibility to developers is actually through integrating into the CI/CD process. So imagine, as part of the infrastructure as code that's being developed by engineering teams, you could actually provide a way to scan that infrastructure as code right at the time of pull request and provide them with actionable right-sizing recommendations before they even deploy it into the Kubernetes cluster. And that's what we're looking to show here. This is an example I'll kind of show in GitHub in a moment, what this might look like from a GitHub standpoint. But here, let me just go share this tab. You might see here, like, if I'm a developer, I'm going to go ahead and modify some infrastructure as code files, and when I do that, I can get feedback right at the time of that modification of that file around various different types of FinOps related or cost related issues. And so things like missing labels, you can give that feedback to developers then, or you can also give them things like, does the container that you're modifying the infrastructure as code for, does that need to be right-sized? And this is a great example of Insights kind of automatically finding that, mapping that infrastructure as code file to a running workload and pulling in the recommendation so that developers can fix it right then when the infrastructure as code is being changed, without and reduce and potentially save and avoid wasted cost, so that that doesn't kind of build up and cost you money down the road. So this is a very powerful way to kind of push that information to developers. The other way that you can kind of share that, get that information out to developers is by this concept of admission control. And so there might be scenarios where at the time of deployment, you want to, prevent misconfigurations, like workloads where there's labels missing, for example, from getting into Kubernetes. And those are some other ways that you can also kind of enforce these best practices. So I think the high level takeaway here is, getting engineers to take action is another side of this coin that a lot of organizations kind of miss, right? It's one thing to get the resource recommendations like we shared, but it's another thing to make sure that developers can get that into their development process and get the information that they need in order to take action. And that's one of the critical ways that I think Fairwinds really helps organizations around right-sizing and helping avoid sort of that wasted compute. So that's our quick demo. I mean, the Fairwinds Insights platform is fairly comprehensive. It covers more than just cost, right, and right-sizing. It can also do runtime vulnerability scanning and help you enforce Kubernetes best practices across reliability, security, and efficiency. So if that's something that you're interested in, we do offer a free tier that you can check out. So what I'll do is, now that we kind of gave that quick demo, I think we have our final polling question for today. And based on everything you learned in today's webinar, I'd be curious if you're looking to right-size your Kubernetes environment now. Is that something that's on plan that you plan to do, and how soon do you plan to do that? And so I think Cody will kick off the poll for this one.
And Joe, I'll just add while we're waiting, like having, been an SRE at a relatively small company, some of these recommendations are really straightforward, but it's really tough to do this at scale. When you have tens of clusters or, you have hundreds of workloads, it's really tough to be able to keep tabs on everything. So this is great. And I think also just like being able to choose at which point to intervene is awesome as well. Having it in the CI pipeline, having it as a recommendation, having suggestions that you can apply. This was something I was really excited about before I came here to Fairwinds.
Awesome. Yeah, that's a very good point. I think, like you said, doing this at scale is really the challenge, right? And what we find is organizations like platform engineering teams that have to serve the needs of dozens of development teams need a process and a solution that not only generates the recommendation, but gets that into the development process. So, really kind of interesting to hear that. It looks like we've got about a little more than about half of the audience looking to do right sizing within the next kind of 1 to 6 month time frame. And then looks like the other half, they don't currently have plans to right size. I think a lot of organizations actually don't have plans to right size. And I think it's one of these problems that they don't, that kind of reveals itself once you sort of install a tool that specializes in right sizing to help you quantify how much potential over provisioning may exist in your cluster. And so again, a lot of organizations really don't know how much they could potentially save until they install a tool and get that estimate. So that could be a way to kind of help build the business case and show management, hey, there's still additional opportunities here. But at the same time, it looks like at least a majority of the folks here do have some plans in the next kind of 1 to 6 months. And I think we'll start seeing that this becomes more and more of an important problem for organizations to solve as they adopt containers at scale. So I think with that said, we just gave that overview of the Fairwinds Insights solution. It is a fairly broad platform that includes not only the right sizing and cost allocation tools, but it also integrates policy enforcement and developer guardrails so that you can, right size, but then enforce and ensure those best practices are consistent going forward. And really the goal is to enable, organizations to ship their applications quickly in an automated way, but also be able to, give that platform team a way to manage and control, resource usage in their multi-tenant or clusters. So if you are interested, we do have a free tier. It's something that our sales engineering organization can help set up for you. The free tier is actually full featured. Every feature is available. It's only limited actually by usage. And so the free tier is for organizations up to 20 nodes and 2 clusters. And so if you would like to try that out, feel free to kind of check us out at fairwinds.com and click on that Get Started button in the upper right of the screen. So with that said, I think maybe we'll turn it over to Cody to see if we have any kind of questions or from the audience, and we'll go ahead and maybe move towards wrapping it up at that point.
Absolutely. So Joe, it looks like we've received a couple questions, and I'm just going to kind of take them from the order they came in.
Yep.
Says right here, do you think it is a good idea to define what is the reasonable resource limit that these pods are going to use based on consumption? Or is it more prominent to consider the nature of the process running?
Yeah, great question. I don't know, John, do you want to try to take that one first?
Sure, yeah. This is a debate I got into a lot when I was doing more kind of site reliability work. I think it's better to kind of look at your actual utilization being used, because unless you're in a very strict industry where there's lots of formal verification, you're probably not going to have a lot of guarantees about like the theoretical resource usage, if I understand your question correctly. So you probably have a memory leak in there somewhere. There's probably a bug somewhere that might cause certain undesirable behavior. So I think usually in those cases, you want to just focus on what's the actual utilization being used. And in cases where you need to be very reliable, using the peak hours, peak load, and kind of anticipating spikes in load is a good thing to do. So maybe you build in a little bit of headroom for your CPU and memory requests. I hope that answers the question.
Cool.
All right. Well, if that didn't answer the question, Hiram S., who submitted that question, just go ahead and let us know. Send in another follow-up if you need to.
Yeah, thanks, Hiram. That's a good question.
Awesome. So moving on to this next one, I'm going to go ahead and put the whole question on screen, but I'll shorten it. How can you talk to setting no limit on memory? Kind of what are some of our defaults here?
Yes. Yeah. So basically you have all of the available memory. And if there's no request set, those are also just going to those are all equally weighted. And at some point when you run out of memory, it's sort of a crapshoot which pod gets terminated at that point. I think in the case, I'll have to double check, but I'm pretty sure you can use memory as, I think it's in a certain version of C groups, but essentially you can use that memory request as a suggestion to prioritize that workload. It's a bit different from CPU though. But yeah, in the case of no limits, you get the whole thing. So you're on the other hand, right? You're losing the guarantee that that a random pod in your node won't be terminated prematurely.
Awesome. We've got a lot of questions rolling in. So
I can take a couple here too, Cody.
Go for it, Joe.
I'm looking at it. Yeah. So we may not be able to answer all of them, but these are definitely some good questions. I think one of the ones I'll take from Lynn is, what challenges do organizations typically face when it comes to sizing the Kubernetes cluster itself? And John, I don't know if you have any guidance on that.
Sorry, repeat it one more time.
Yeah. So what challenges do organizations typically face when it comes to sizing the Kubernetes cluster?
So usually I think it's just over provisioning. So like I mentioned with early adoption, you're either not setting reasonable limits on your node pool size, and then you're most often, if you're using things like Helm charts, you're using default request values, and those things can just kind of balloon up without you even realizing. That sort of tracks with what we hear from our customers, that usually over provisioning is the biggest problem, more so than under provisioning. But then I think when you start talking about under provisioning workloads, you have to kind of have that quality of service conversation, and it's really important. So yep. I think the shorthands that we have in Insights are a really good place to start, but obviously at some point you'll have to look into actual data structures and algorithms and things like that to really optimize your software if it's in the critical path. Yep.
Good question. I'm going to move down the list to the last few. So one of them is how can you send metrics to Fairwinds? So what Fairwinds uses is actually Prometheus in order to generate all the usage metrics that we shared in the demo today. So you can either install Prometheus via the Fairwinds product. We provide our own configuration of that, or we can connect to your existing Prometheus instance. There's another question around how do you reveal idle or under provisioned nodes via the UI? So we actually do have, we didn't do this in the demo just now, but there's a page called the capacity page that gives you sort of a high level view at a cluster level, your utilization for nodes, both from like how much are the nodes, how much of the memory and CPU is requested versus how much is, what are the limits set to. So there is a way to kind of identify under an over-provisioning there. There's also a way to look at, this might answer Shridar's next question around what's the first indication of your K8s environment being over-provisioned. We do have a chart that shows you kind of the full capacity of your cluster. So how many, for example, CPUs or gigabytes of memory are you, does your cluster have as total capacity, as well as how much are you actually utilizing. So that's another view into the product where we can give you the view into that over the last 24 hours, as well as on average, what have we seen over the last 30 days in terms of overall kind of actual consumption across your nodes. And most of the time we see organizations have lots of extra capacity from a node perspective that they're not utilizing. And so that's a first pass at kind of identifying the clusters in your organization that might need to be right-sized. And then I think the final question is around, is there a mathematical formula to right-size Kubernetes? And what we were sharing earlier around this concept of quality of service really has a few different, formulas, if you will, for how right-sizing recommendations come out. And that allows you to kind of select a quality of service target based on your desired business criticality of that workload. So if it's very critical, you may want to actually give it some extra headroom, or if it's a workload that is just running in the background that isn't serving up a critical business need today, you may give it a different recommendation that allows it to use a different amount of CPU and memory. So we do have some of those options in the product. But I think that's a majority of the questions here. I think really kind of good conversation today and good questions from the audience. I think if you're interested in right-sizing, there's really two options for you. You can check out our Goldilocks offering, which is on our open source Git repo at github.com/fairwindsops. Or you can sign up for our free tier of Fairwinds Insights, which is really the enterprise version that adds a lot of additional capability there as well.
All right. Well, Joe and John, it does look like we've received one final question, if we can squeeze it in.
Yep.
It says, if you are using AWS EKS, do you still have to right-size Kubernetes?
Yes, I believe you do. And so I'll move that over to John.
Yeah, so I've had less experience using EKS in production, but you will still have to pay attention to, you still have a lot of choices to make, right? Like node instance type, quality of service. You're still going to have to look at requests and limits and make your own determination, right? There are, a lot of tools coming out to help you do auto scaling. But you still need to kind of be cognizant of, what your reliability requirements are, what your availability requirements are, and make sure you're dialed in based on that. I don't know I know GKE, for example, is coming up with some cost tools, and I'm sure Amazon has some version of that. But really, it's you kind of need to use your own judgment to right size.
All right, Joe, anything to add, or are we ready to close things down today?
No, I think that's a great summary, John. I think it does probably vary from cloud provider to cloud provider. I think right now, the right sizing problem ranges from node right sizing to container right sizing, and I think the container right sizing is still the consistent problem across all the clouds today. So,
yeah, and I think if you are, you can look at the cost opportunity, but you don't have in those platforms any notion of quality of service, and I think that's an important thing to consider when you are trying to right size your containers. So,
awesome.
All right. Well, John and Joe, I really appreciate you guys coming on to Techstrong Learning and spending the last hour with us. Really appreciate you joining us today.
Thank you.
Yeah, thank you.
So just a couple of closing remarks for our audience. Don't forget to check out Fairwinds Insights. Those links are still in the chat if you'd like to scroll up and grab that. In the chat, you'll also find a link to our post-webinar survey. If you wouldn't mind filling that out for us, we would love to hear your feedback. So just a couple more things. We will be sending you a email of our recording of today's session. You'll be getting that here shortly, or you can also find the recording living on the Cloud Native Now website. That's cloudnativenow.com/webinars, and you'll find it in the on-demand section. We will be selecting 2 of our most engaged attendees to receive a $50 Amazon gift card. So we'll be selecting those as soon as we close, and I'll be contacting you here shortly. So Joe and John, thank you once again. I'd like to thank Fairwinds for sponsoring our program. And to everyone who is here still, thank you so much for joining us today. We appreciate your time, and we hope to see you at a future Techstrong learning experience. Have a great rest of your day, and you may now disconnect, everyone. Thanks again, guys.